Hey everyone, today I'm sharing my journey training Resnet50 from scratch on Imagenet. After 7.5 hours of training and multiple optimization attempts, achieved 77.09% top 1 accuracy, which places me in top 10% of from scratch training results on Imagenet. I'm really proud of that. Let me walk you through the technical challenges I face and how I solved them. Initial challenge was getting the Imagenet data set itself. So initially I tried Kaggle Stay Live, but I was facing issues with my instance. My instance was getting crash, and I was using spots for some time, but I was not aware like whether it was a spot domination or the instance was not able to handle Kaggle and was not able to troubleshoot that initially, and then it kept on crashing. Then I noticed the metrics and everything was going up and then going down. Although I associated my instance with the EBS volume of 300 GB, it was not getting added to that particular EBS volume. um, so there was a lot of issues as it kept on crashing down. I was not able to troubleshoot it properly. So instead of wasting a lot of hours on troubleshooting it, I instead went with alternative approaches. And one of the biggest problem in Kaggle Stay Live is it was not even showing the progress bar, which is the biggest blocker for me. I was not even able to understand like what was happening. So instead of downloading my Kaggle, I tried using HF, and that is Hugging Face CLI, and it was really fast. So I could download my data set within 2.5 to 3 hours, and I went to Hugging Face, created that account, and agreed to the terms and conditions, and after that I could download it. So once this downloaded around 150 GB of image data to my EBS volume. So I trained on next was training. For training I had to decide like which instance I would use. Initially I was thinking of using the G4DN itself, and then I used the G4DN instance, but it was way too slow, and it was giving me like 20 minutes in epoch. I was not patient so I was like, okay, I'm gonna use a bigger instance which better, and it was a single GPU, so that was another problem. So I wanted to try the distributed training so that I could finish the training faster. So instead of relying on G4DN, I moved to P4D 24x large, and it provided me 840 GB GPUs. Okay, so that's a massive parallel training capability with 1024 effective batch size across all GPs. That's the one that I use, and total epochs was 100. Initially I trained for 90 epochs, and after that 10 for fine tuning. My strategy was to first test it on a smaller Imagenet model itself. Data set itself. So I created a mini Imagenet data set for myself, and using the bigger one, and then trained tested my pipeline on that. It after it gave me promising results, I moved to the complete training. So and after that, during training I did encounter a few issues which I didn't notice during the on my smaller Imagenet data. There were some corrupted data sets, data images. Only one, not all. Only one image was corrupted. So because of that, my initial training itself failed. So after removing this and making my code robust to handle those corrupted images, I could complete the first training without any issues. So that was good, and I could achieve 76.7% accuracy with 90 epochs. And now coming to the strategy, I used SGD optimizer, and with cosine annealing LR of warm up of 5 epochs, and the batch size was 1024. It was 128 batches per GPU, and the loss cost and triple loss with label smoothing worked beautifully for me. Can again touch AMP FP16 mixed precision. So now, also on top of that, the augmentation, I haven't used any advanced augmentation techniques here. I use the basic ones, that is a resize crop, horizontal flip, color jitter, random erasing, and normalize as normal. So these are the ones that I use, and this itself gave me 76.75% top 1 accuracy. So this was on the range of 90 epochs, and after that the next one was fine tuning with LR restarts. So as I already achieved a good accuracy, I wanted to push it further. So instead of retraining from scratch again, I would be using from the checkpoint. So I use the best accuracy checkpoint and then started fine tuning on them. I used multiple LRs to see like where it would work, because initially like as I used cosine annealing at that time, when I saw the 89th epoch in the previous learning training attempt, the LR was almost zero. Okay, so there was not much I could use or decide on which LR would work for fine tuning. Okay, so because of that, I had to decide on which would work and test it out. So the um, uh, I ran three systematic experiments. First one was LR equal to 0.001. It was too aggressive. Okay, so model oscillated between 76.5% and 76.9%. Maximum much it could achieve was 76.88. Okay, it obviously went above 76.7, so it was good, but still oscillating. Okay, so it couldn't converge to a stable minimum, and after 17 epochs it peaked at 76.8, and after that started oscillating. I was like, okay, so this is the time I have to stop, so I didn't go ahead with that. And next I stopped the training, and then next went with LR.00, half the value of previous one. So this one I ran for 20 epochs, and again same strategies, cosine annealing, and it does achieve the best accuracy that I have logged in this training, that is 77.09%. It was the best result achieved. And after that third attempt, then I wanted to see like if I could still test and see whether it would work. So whatever is the value between these two, so that is 0.0003. So this one I ran for 14 epochs, and this also topped to 77%, but didn't move ahead after that. So from these experiments, what I got to know was 77 might be the ceiling point for my model. Like it might have hit that ceiling spot. Like I tried different techniques, but still it was not going above that. So I was like, okay, this time to stop right now. So I stopped it this time, and if I had to test with different techniques, I would maybe check with different augmentation techniques or the optimizers or different things. So right now I just stopped at this, as I have already achieved the required accuracy. But yeah, I know 78% is the more than 78% is the one which will give you maximum score. So my plan is to get there. Maybe I'll see if I can try test it with the other techniques that's already submitted by Dawn, submitted Dawn mentioned of this. Also tried progressive resizing and the other cut mix and other techniques, but it didn't give me the expected value, so I didn't test it out much. But I'll give it some other give another go some other time and see whether it will increase. So that is about my project. And now coming to the training logs, you can see the training logs here. So this is the complete 1 to 90 epochs, and the best was 76.75. It was achieved at 89th here, and then total time was 6 hours 30 minutes. And after that, this was the fine tuning that I use, and here I achieved the 77.09%. It was at the epoch 99, and this is the additional LR experiments. Okay, so key finds that I have learned is this particular training model that I have used with standard techniques, basic augmentation, platelets at 77%, and we could use multiple LR restarts to fine tune the model and push the accuracy a bit higher. But again, there is a ceiling point and it will hit it and it can't do anything much. So the only other things that can be considered maybe is different augmentation techniques and different optimizers, and then see whether that would work for us. And the important hit of this project that I basically learned is the distributed training. The GPUs are so fast, and initially my GPUs were not at 100%. There was a lot of bottleneck issues from EBS volumes. So although I used 300 GB, all the storage was good enough. The IOPS limit and throughput was not good. So I increased the IOPS limit and also throughput, and once I optimized EBS, I was able to hit 100% on all of my GPUs during training, which was a feast to see in the logs. So that was good. And then batch size was 1024. I also tried 2048 in another model, but that didn't work greatly for me. So, and also there was some memory constraints at the GPU level itself, so I didn't go ahead with this. Just went with the 1024, and 1024 worked beautifully for me. And then label smoothing, so, and with cosine annealing, that worked magic. So like I could see the learning rate improvement in the detailed training logs that I have, and I could see my model learning sometimes very slowly, but still there was like little step ahead, and sometimes just oscillating between the peaks. And it's like okay, so I could learn a lot from these, especially the hyperparameter fine tuning and the distributed training. And yeah, this was a good experiment. Thank you. If you would like to test it out, maybe you can run the code here. You can use this GitHub and test it out. Okay, before we stop, I just want to try the model, and let me just bring that. Okay, so I have already uploaded my model to Hugging Face, and this is it. So let me just drop some images. We can also use, I have already added few examples here. You can use that. And jellyfish, so yeah, sorry, goldfish. So this is the goldfish, so you can see 87% accuracy. And now if we go with the tiger, 78%. And I have doggy, golden retriever, 85%. This is great. We can also see what other things it could be classified as. And this was okay, this was, I'll see again here. Yeah, this one is Australian Terrier, Yorkshire. So you can see the all the accuracy classification, so classification results here. This is great. And if you want to test it out, we can also download directly from let's see which would work for us. Maybe I'll download a cat. Okay, let's see. Save image. Okay, and then I'll just gonna upload those here. Okay, tiger cat, tabby cat. It's confusing between these two because I think it has the characteristics of tiger cat here and also tabby cat. Okay, now let's try one more that I've already downloaded. There's a sunglasses. Yeah, sunglasses. So it's confused between plural or singular. So there's only one, so it is 22% accuracy, which is great. So yeah, this is my model, and thank you all.